for the next presentation. Now we move on the fourth presentation, for which I invite Professor Dr. Sanjay V. Patil, Head Alcohol Technology and Biofuels and Technical Advisor, PSI Pune, to make the presentation on critical investigations in sugarcane juice syrup processing to ethanol production. Sir, you have 20 minutes for presentation and 5 minutes for question and answer. Welcome, Dr. Patil.
Good evening, everyone, and let me thank STI for inviting us to make a presentation on this important topic. And my today's title of presentation is Critical Investigation in Processing of Sugarcane Juice and Syrup for Ethanol Production, and my co-authors for this presentation are Dr. Konde and Mr. Sugarcane Patil. This is the outline of my presentation. Without going through this outline, I will straight away go to the presentation. So the highlights of the ethanol blending program are that to achieve 20% blending by 2025, we require about 9,000 million liters of ethanol. And of this 9,000 million liters, 6,600 million liters is required to be supplied by the sugar industry. And to produce this 6,600 million liters of ethanol, about 6 million metric ton of surplus sugar would be diverted to ethanol production. Probably all of you must be knowing that the sugar production in this season will increase to about 31.45 million metric ton, and about 3.4 million metric ton of sugar will be diverted through sugarcane juice or syrup or BAV molasses for production of ethanol. And in this season probably will be achieving about 8.5% ethanol blending in this season. Coming to the feedstocks availability, probably all of you know that sugarcane crop have different varieties and different sugarcane yields. The sugar percentage or recovery in sugarcane depends on many factors such as geographical region, harvesting time, temperature, soil, etc. So during the season, the sugar in sugarcane is going to vary, and the harvesting condition as well as the transportation facilities can also influence the sugar recovery. So sugar concentration in the sugarcane juice has a very important role in determining the final alcohol concentration during fermentation. So the juice and syrup, as all of you know, that it is perishable and can get easily contaminated. And therefore, in mill operation, if it is interrupted for more than an hour, the contamination level can increase in the juice, which can be carried further to the fermentation. To avoid contamination in mill section, the mill sanitation and the hygienic conditions should be proper, and the mill should be kept in dry condition during the long shutdowns to avoid stagnancy of juice in the mill section. These are the characteristics of the cane syrup as compared to the C molasses and BAV molasses, and you can see that though the TRS are almost similar as in the case of C molasses, the unfermented sugars are less, and the most important factor is the F by N ratio, which is fermentable to non-fermentable ratio. It is quite high in the case of sugarcane syrup, and that's why our fermentation efficiency can be higher, and that's why we can get higher alcohol concentration in the fermented wash. The volatile acidity is also lower as compared to C molasses. The only problem with the syrup is that it is perishable, you cannot store it, and therefore you have to use it as soon as you divert it to the distillery. Coming to the sugar manufacturing process, if you are manufacturing plantation white sugar, Generally in our country, we do the double sulfitation, but for fermentation, single sulfited syrup should be used. And the presence of the high amount of sulfites, which are inhibitory to the yeast, it is the reason why we require longer retention time in the fermentation, and it is about 40 to 42 hours. To reduce the fermentation time, you have to select a proper yeast strain, and you have to also maintain a proper yeast count in the fermentation so that your fermentation progresses faster. You have to add a good amount of nutrients and additives, as the syrup or juice will have some deficiency of nutrients. So you have to add them in the pre-fermenter as well as in the fermenter. If you are producing raw sugar, then of course you use the desiccation process, and this is very good for the syrup fermentation. So we have seen that wherever we are manufacturing raw sugar, our fermentation retention time is about 28 to 30 hours as compared to the double sulfitation method, where our fermentation time is about 40 to 42 hours. The bricks of the syrup is generally about 55 to 60 bricks, which can be partially or totally diverted for fermentation, depending on the capacity of the distillery, and of course after cooling. The bricks of the syrup should not vary substantially, which can affect the fermentation process control. In fact, this is the problem we have seen in many plants, that the bricks of the syrup is varying between 45 to 60 also. Then it becomes very difficult to control the fermentation process. So we suggest that the bricks can vary, but it can vary between, say, about 55 to 60. So the syrup of 55 to 60 bricks can be further diluted to about 28 to 30 bricks, either using recycled spent wash, or we can use secondary juice also, or even clear juice. And we are of the opinion that if we can use clear juice for dilution of the syrup, it will reduce the inhibitory effect of the sulfides in the sulfited syrup, and that will improve your fermentation efficiency. One can use also syrup at about 28 to 30 bricks. So we can withdraw it after the first body and can be used for fermentation without any dilution and after cooling. But of course, as mentioned by Professor Naren Mohan, in this case, you will have to see the vapor balancing of the evaporator station. The sugar syrup cooling and preparation system should be closed type to avoid any kind of contamination. The syrup transfer pump area should be kept clean and contamination free. The syrup buffer tank retention should be minimum. The syrup transfer line from mill to distillery should be minimum, and it should be leak proof. Proper cooling arrangement should be provided so that syrup temperature is maintained at around 35 degrees centigrade before feeding to the pre-fermenter or fermenters. So this is the typical syrup cooling system which is used in our distilleries, and this is as per the DFPD guidelines. So you have to have 2 mass flow meters, and of course we usually have a load cell type weighing system in the distillery, which can measure the quantity of syrup being taken in the fermentation house. As far as fermentation is concerned, in India, we use typically fed batch fermentation with four fermenters, and we can target for about minimum 13% alcohol concentration in the fermented wash. And as far as yeast culture is concerned, we recommend to use a combination of active dry yeast as well as pure culture. You can maintain a cell count of about 3.5 into 10 raised to 8 cells per ml in the pre-fermented, and about 2.5 into 10 raised to 8 cells per ml in the fermenters. You have to transfer minimum about 12 to 15% of the pre-fermenter, which is fully propagated for the fermentation to progress properly. You have to do routine microscopic examination by withdrawing samples from different points as well as the fermentation broth sample in every shift to see the level of the contamination. And after transfer of every batch of fermenter, the fermenter need to be properly cleaned and sterilized with formalin and steam. The fermenter pH is to be maintained between 4.2 to 4.5 using either liquid ammonia or other ammonia source. Then you have to add the required quantities of nutrient and additives in the fermenter, and we suggest that these quantities of nutrients and additives should be distributed in 4 intervals at least based on the progress of your fermentation reaction. It is very important to maintain fermentation temperature at about 33 to 35 degrees centigrade. We have seen that in some of our visit to the North Indian distilleries, we have seen that the fermentation temperatures were quite below 30 degrees, particularly during the winter season. So one has to take care to bring the temperature to 35 degrees centigrade. That will improve your fermentation rate. In fermentation, contamination by lactobacillus and wild yeast need to be examined routinely with judicious use of antibiotics and antimicrobial agents and using good manufacturing practices. One can use mixed juice also for fermentation, but it will result into lesser alcohol concentration in fermentation broth of about 7.5 to 8%. But it will also take vessel retention time about 12 to 14 hours retention time. But then, of course, your steam consumption in distillation will increase. But if you use mixed juice for fermentation, your pH is going to fall below 4 during the fermentation, and this will also result into higher quantity of spent-wash generation because of the lower alcohol concentration in fermentation. So these are the typical doses of nutrients which are used in the pre-fermenters and fermenters. These are the typical doses for 60 KLPD distillery. Of course, this will vary from mill to mill, but these are the typical details. Coming to the syrup fermentation again, we can target for 13% alcohol concentration, and with the sulfited syrup, it can take about 40 to 42 hours to complete the reaction. In one of the cases in North India, they called us where the fermentation time was about 50 to 52 hours, and we were able to reduce it to 40 hours by doing fine tuning of all the parameters which I have suggested. The residual sugar should be below 0.5% or below that also, but if the residual sugar is higher, about 2.5 to 3%, then that means your fermentation is not progressing properly and you are going to lose some sugar. As I said, that spent wash produced can be recycled back to fermentation process to minimize the fresh water requirement and of course to reduce the quantity of spent wash. For juice as well as syrup fermentation, the maximum quantity of fermented wash need to be transferred to the wash settling tank before CIP and cleaning of fermenter so that there is no residual fermented wash remains in the fermenter, which can bring in contamination in the fermenter. This is the typical graph of spent wash generation versus the alcohol concentration in fermented wash. So you can see that if you achieve 13% alcohol concentration, your spent wash generation will be about 6 liters per liter of alcohol produced. And these are the characteristics of the spent wash generated. You can see that with the spent wash recycle, you will be able to reduce the quantity of spent wash generation to 3 liters per liter of alcohol produced. Your COD will be about 50,000. So that means your quantity and your pollution load both are going to get reduced if you use cane syrup for fermentation. These are the typical photographs of the spent wash generated. So you can see that color of the spent wash is also reduced when you are using syrup for the fermentation. So this is the spent wash recycle typical system which is used in distillery. So you should have some magnetic flow meters to measure the quantity of spent wash which is going back into the fermenter. Coming to the distillation, we face some problem in the distillation also because of the acidic nature, because the pH can go below 4 and that can result in corrosion and damage also to the analyzer column plates and bottom segments. We have observed this. Even the reboiler tubes are of the analyzer column as well as the rectifier column are also getting damaged, and even the spent wash transfer lines are also getting damaged. The rectified spirit produced in distillation is also quite acidic. If you measure the pH of the rectified spirit, you'll see that it can be quite acidic and it can affect the equipment, particularly when there is an higher contact time. Coming to the dehydration process where we produce ethanol, the acidic nature of rectified spirit again results in corrosion and damage to the day storage tank. We have seen leakages also. The evaporator column bottom segment leakage has been also observed, and the evaporator column reboiler tube leakages has been also observed, and we have also observed some issues with the molecular sieve because of the acidic nature of the rectified spirit being used. If this ethanol is stored for longer time, there is possibility of ethanol storage, tank corrosion and damage also. But the advantage of using syrup or juice is that you can increase your capacity by about 1.5 times as compared to what you are operating with the sea molasses. Coming to the ETP section, when you are using syrup, obviously, because your pollution load is getting reduced, your biogas production will also get reduced to about 20% of the amount which you are generating with the sea molasses effluent. You can encounter a substantial scaling problem in case of evaporation of spent wash from syrup fermentation. The spent wash will have low calorific value, and the profitability of ethanol production will vary depending on the downstream effluent treatment system being used. As it is mentioned that the incineration route is not really suitable when syrup is to be used as a raw material because the calorific value is less, and the spent wash generation is also less as compared to sea molasses. And you can get the highest profit. In Maharashtra, we have some distillery who have the old environmental clearance where direct biocomposting is allowed, and there we have seen that the profitability is highest, and therefore some distilleries in Maharashtra and VSI has also has given a proposal to the government of Maharashtra for allowing direct biocomposting of raw spent wash generated during the juice or syrup fermentation for the alcohol production. This will definitely improve the profitability of ethanol production using syrup. Because with syrup, there are different routes of effluent treatment which are possible, and with lower distillery capacity, biocomposting is allowed. We can also have a dryer system, but with the change in feedstock, the government should also consider the change in the effluent treatment system, and therefore depending on the capacity of the distillery and depending on the various other availability of the feeds, filler material and etc., there are different routes which can be allowed. Of course, these routes are not yet not allowed, but this is one of the suggestions. Coming to the comparison between Brazil and India, because Brazil produces a lot of ethanol using direct sugarcane juice. So if you compare the two countries, you can see that in Brazil, the distillery capacities are quite big as compared to our capacities. and they use directly juice. They generally don't use directly syrup, and therefore their alcohol concentration in fermented wash is about 9 liters, 9%, whereas we are achieving higher alcohol. We are using fed batch fermentation. Okay, so I think I can skip some of these slides and I will come directly to the conclusion. So it is possible to go for syrup in season and BAV molasses or biosyrup in off season. It is possible to increase the capacity by 1.5 times above the installed capacity while using sugarcane juice or syrup. The profitability will vary depending on the downstream effluent treatment system. Incineration route is not really suitable when syrup is used. Highest profit can be earned if direct biocomposting of raw spent wash from syrup is allowed. There will be reduction in the pollution load. It is possible to divert substantial quantity of sugar through ethanol production from syrup. Thus, we can reduce the increasing sugar stocks in the country. The highest price of ethanol is offered by the oil companies from sugarcane juice or syrup. You can achieve higher alcohol concentration and recycle spent wash, thus reduce the spent wash quantity. The ethanol payment is made by oil companies within 21 days. There is also priority for lifting of by oil companies for ethanol produced from sugarcane juice and syrup. And there are many indirect benefits such as increasing in crushing capacity of the sugar mill, reduction in steam consumption, higher export of power, saving in handling and bagging charges of sugar, and reduction in interest burden on sugar stock. So this is what I wanted to bring to your kind notice. And if you have any question, I am ready to answer these questions. Thank you very much. There is one question by Mr. Narendra Rawat. The age of syrup media of lab culture is increasing. This is probably because of the sterilization. Some nitrogen source is getting degraded, and some ammonium compounds getting degraded. That may result in increase in pH. How can we reduce or stop corrosion from low pH of absolute alcohol to our plant as told by you? You have to change the material of construction. Now for the ethanol evaporation column bottom segment and for the reboiler tubes, we are going for 316 tubes. That probably will reduce the corrosion issue. So this is possible by changing the material of construction. There's one more question. What is the best possible fermentation efficiency? Some of our distilleries have achieved about 92% fermentation efficiency with the sugarcane syrup. This is because the syrup media is very clean and it is very good for yeast to ferment it to alcohol.
Sir, there is a question by delegate from Satish Sugar, that is quantity of sugar consumed by bacteria if syrup volatile acidity is greater than 12,000 ppm.
Thank you, Dr. Patil.
Thank you very much.
Almost all areas are highlighted, and the important topic you have covered very nicely. And also you have given the solution for the corrosion that you have suggested to use the SS quality 316. This is also a good solution for all the industry. Thank you very much.